Minasan, konnichiwa. Zamurai Engineer this. Welcome to the first hybrid national convention with the theme defining post-pandemic agile strategies for mechanical engineering community, mechanical engineers, certified plant mechanics, and ME students. From your professional organization, Pambansang Samahan, Inhenyerong, Mekanikal. This November 26 to 27, 2021. Friday, Saturday at 2 to 7 p.m. So we have the contact details of the PSIM, and our topic for this slot, for this time slot, is about mechanical engineering and research, the winning Japanese perspective. And this time slot room track is for ME students. So we are going to inspire, challenge the mechanical engineering student for their future success. Okay? So PSIM, again, Pambansang Samahan ng Inhenyerong Mekanikal. Our specific topic, mechanical engineering research, the Japanese culture of hard work and dedication. This is the winning culture in engineering discipline. So I'm your professor, Dr. EYPEI Yuzantua, assistant professor at Taguig City University. So that is how we introduce ourselves in Japan. In the Philippines, we introduce ourselves like in this slide. So again, I'm your speaker, assistant professor, TCU. I am a alumni of Polytechnic University, PTU, Japan, with a bachelor's degree of engineering, major and precision engineering. I am a former engineering faculty of UP Los Baños, engineering consultant of several industrial companies, technical speaker at International Research Congress, the Empire Hotel, Brunei, Darussalam, 2019, technical speaker at IIEE National Convention at MOA, 2017, technical speaker at Metro South Universities and Colleges National Research Congress, 2019, and technical speaker at PIIE or Philippine Institute of Industrial Engineers National Convention at Cebu, 2019, and many others. I am a production engineer, qualified to be an associate professional engineer in Japan. I am a mechanical engineer licensed in the Philippines. I am an electrical engineer licensed in the Philippines. I am a civil engineer licensed in the Philippines. I am a plumbing engineer recognized in Singapore and licensed master plumber in the Philippines. I am an industrial engineer in the Philippines, having graduated BSIE. I am an instrumentation engineer in the Philippines under the organization PICE, having been passed the examination of the PICS. I think given last 1996, I was the fourth place. I was the fourth placer in that examination. And also I am a licensed professional teacher. So, next. With regards to our topic, which is related to mechanical engineering. So I am a Bachelor of Engineering, recipient of Japanese government scholarship to study engineering in Japan. So my alma mater is Polytechnic University, Japan, PTU. Okay. I am an author of paper published in Singapore, Gamification of Engineering Education, what we learned in engaging mechanical or engineering students in problem-solving exercises. I am a production engineer, qualified as chief professional engineer in Japan. I am a mechanical engineer, not a graduate here in the Philippines, but the Bachelor of Engineering degree from Japan that I earned translated into 3 different bachelor's degree in the Philippines. So I was able to take the mechanical engineering board exam. I was able to take the teacher's board exam, and I am industrial engineer. Okay, because production engineer is under the industrial engineering discipline. I am also a Japan licensed vocational instructor for life. I am a licensed in the Kanagawa Prefecture, having license to teach vocational courses in mechanics, mechatronics, heat treatment, and plastic deformation. I am a member of the Rota Mechatronics Laboratory, which developed the Rota gearing system, wherein I also produce, construct, design, and actually presented a thesis with the title A Novel 2-Degree of Freedom Robot Joint Mechanism. So in Japanese language. So I am a second generation. So the second step improvement of the Hirota gear system. So my senior researcher developed a 1:76 gear ratio. I am the one who developed 1:100. 1:100 gear ratio. So with a very small casing, can fit in a very small casing, 1:100. So that is the joint mechanism, because you can get so much force by using a very small motor, drive motor. So that is the case for the thesis. I am a graduate of several degrees, PhD, MBA, BSc, BCE, BSIE, BSPD, with online diploma from Harvard, McGill University, and Johns Hopkins University. I have more than 16 years teaching in engineering, which include 10 years teaching in PSME. 14 years field experience, various positions, starting from the bottom up to engineering manager, R&D manager of a Japanese company, including 10 years in Japanese companies, 4 years of which is in Japan, in Sagamihara City. So that's all for your speaker. We are now going to introduce our topics. So I divided our topic for the day on 4 sub areas. So BSME career, what do we have to expect? Number 2, research. Number 3, engineer. And lastly, key summaries. So the contents will run like this. So BSME career, academic and field, and research and engineering. So these are what we expect in our mechanical engineering if we are talking from the point of view of the Japanese. So we are either going to the academy, which is more on research rather than more on lecture. So in our country, we are more on lecture. Our teachers are more on lecture. But in Japan, they are more on research. And they have responsibility to teach, but the percentage of the concentration is more on research. And the other one is field work, wherein if you are in the field, you are actually called an engineer. So if you are called an engineer in Japan, you are either a licensed engineer or a technologist or a technician. So we have 3. No? The same is true in our country, wherein we have what? We have Washington Accord, which define the standard of recognition and engineering, and we have the Dublin Accord, okay, for technician, and we have the Sydney Accord for technologies. So actually the lowest is technician, then technologist, and engineer. They are all called engineering professional. For example, in our discipline, mechanical, they are called mechanical engineering professionals, all of them. So they are working in the field, they are basically called engineer. Any of them is called an engineer. And if you are graduate of engineering, but you choose to be in academe or in research, you are either called sensei or teacher or researcher or scientist. You are not usually called an engineer. Okay? So that is the difference. You are graduate of engineering and maybe you are a member of a mechanical engineering association. Okay? Japan Society of Mechanical Engineers, or in my case, we are a member of Japan Production Engineers. Okay, so you are a member of an engineering society, but you are not called actually an engineer. You are either a scientist or a sensei. Okay, because you are in the research. Okay, sensei because you are a teacher, teaching somebody. Okay. So therefore, we have to talk about one of the main career path of graduate of engineering, that is research. If you are doing research, of course you are a sensei. Sensei in Japan is respected. Okay? The highest respect. Unlike in our country, so sensei has the lowest respect sometimes, or most of the time. Okay? Most of the time, we have the lowest respect. Okay? But in Japan, they have the highest respect. Why? Because of the research culture. They are producing small improvement every time they have research result that could be presented in an academic gathering. Small and small improvement would result in a big technological breakthrough sometimes, most of the time. Okay, and this technological breakthrough usually in terms of technology, skill, and knowledge are usually converted into commercial product. Usually converted into commercial product originating from academic laboratory, like what we had. We are a member of Hirota laboratory. There are commercialized products coming out from the laboratory. They are being commercialized with what? With academe and industry partnership. Industry meaning there are production companies that will produce or test the products, the research result that you had in your laboratory. So, therefore, you have a sense that academic research is oftentimes higher than what they are doing in the field, in the company. Okay. So, for example, we have engineering problem solving cycle. They are doing that because really what we are seeing in the jury, they are practically doing this in the practice. Small improvement. What we can compare in our country, if you, for example, made a research in your school, next year, everybody forget your research result. And not only that, anybody forgets your result, no one will use your result. Unlike in Japan, because you are a member of a laboratory, minimum, there is one or two that will use your research result because your junior schoolmates will continue the process of rotating ruling the improvement. Okay, so that's why I said a while ago that one of my senior in the same lab is the first to construct the Hirota gear system with 76:1 gear ratio. I am the next one, so I have to improve on that. So what is the improvement? Therefore, 1:100. Okay, 1:100. So 1:76, 1:100. So small improvement. Actually, if you are looking at 1:76 and 1:100, that's a very big improvement. However, I have so many other limitations in my thesis. So I would not see it on my own that I made a very big improvement. I am content enough to contribute with a very small improvement. Okay, so the following junior student that could be a member of the same lab will continue to improve, okay, the gear mechanism. So in that way, your research result will not go in vain. Unlike in the Philippines, you are the only one who will talk about your own research, and no other person will. Okay, that is the minimum. And because that is Japan, they are being used in other countries which are waiting for Japanese laboratory research result. Okay? No other countries in the world will wait for research results coming out from our country. That is true, and that is not a good one. It is a true. While, for example, in the US, Japan, or Germany, their research results are being weighted by not only companies but other research laboratories. So that's why their research results has an impact on other topics later on. They will be proposing an improvement on your thesis, on your result, on your research, and that's a good thing because your result became a step. For example, you have a stairs, you have a ladder. In a ladder, you need all of the steps. You contribute to one step, and that is so unlike in our country. You have to do the whole ladder, and that is almost always impossible. Our research result will not equal to the quality of research that the Japanese research laboratories are producing. So very sad state of our research because our academy are mainly focused on teaching. We are so much into theoretical. Theoretical is not actually engineering. What we learn in the theory almost always not usable in practical application. You have to modify the theory to be used in actual. Okay? So theoretically, those are what we learned are important. But if you apply those without any modification, that will not work. Even a simple Newton law will not accurately will not accurately predict the actual physical phenomena. Okay? For example, force is equal to mass times acceleration. You can do it, but for a certain degree of accuracy, maybe that is what we call it academic scale. But if we are talking of commercial application of that, it is not acceptable. So you have to modify. Okay, so push the research into commercialization by studying life cycle. Okay, meaning the research will not end in the design or in the construction. It is up to the maintenance because it is a cycle. Okay, for example, we have an EPIC seal that a company have to produce, and before the company successfully produce an acceptable EPIC seal, the company became bankrupt. The company name is NSCP. They become bankrupt by focusing on the acceptable level of EPIC seal. Sealing, for example, engine seal. This is actually an engine seal. If you are not familiar with EPIC seal is a critical component in rotary engine. Okay, that's rotary engine. Japan is not the inventor of rotary engine, but the efficiency, the effectivity of the engine that Japan produced compared to those made from other countries like Germany. Germany is I think, the inventor of rotary engine. But they are not producing the acceptable efficiency, engine efficiency. Okay? Because there are always practical problems that will arise if you made the actual engine. Okay? For example, here in this engine, too much leakage will arise. And leakage, we have to seal the nut. So, EYPEI seal is a critical part of this rotary engine. Okay. For example, another one is the invisible cloak. So when you use this cloak or clothing, you will become invisible. So there are research on quantum steel material, wherein the theory says that you have to redirect the light passing through the cloth so that you cannot see the person, for example, behind the cloth. You only see, so it is redirected versus time, because so you have a cloth. Immediately behind the cloth is a person, for example, and you cannot see that. But behind the person, there is a background, and you can see that. So there is a redirection in some way. The light rays, the optics will pass through the cloth and redirect its versus time. The rays are redirected, and again, normally afterwards. So there is a range of there's a range or a space wherein we can say that that area created a blind spot. Okay, there's a blind spot. Okay, small area that became a blind spot, and if you locate yourself in that blind spot, you will not be seen. So you are becoming invisible. You become invisible. So you can use that cloth and you will become invisible. So that is one of the research. Now, that is for the research field. How about if you go to become an engineer, meaning you are working in the field, you are going to do the hard work, the manual work, that is engineer work. Design, construct, and maintain. So design, you have to do the real thing using tools. Construct, even more focus on manual. So the manual percentage of design, construct, maintain are really increasing, increasing. In maintenance, almost all manual. Okay, so we can say there are products like nanotechnology search about 25 years ago. They are selling the nanotechnology search in the mall, the stores, in the supermarket. For a nanotechnology is just starting to be developed in other countries. But other countries discover or initiated the research on nanotechnology. However, Japan are the number one commercial creator of products with nanotechnology, like search. What is nanotechnology search? That is also called unstainable search. For example, you have clothes like this. If this is nanotechnology, then you can put dirt like dye. Okay, you can put dirt, but you don't need to wash it in order to clean. You just what? You just you can easily take off the dirt because the dirt cannot pass through the fibers in between separate fibers. So they cannot pass through. So what can you do is just vibrate the dirt, and the dirt will eventually separate from the cloth itself. So it will become clean again. So just vibrate. You don't need dirt for to wash. Washing is for what? Only for odor. Okay, it's the only purpose of washing, because you can just break the shirt and it is clean. So another research therefore is just to eliminate the odor. So if you can eliminate the odor by just vibrating, so it is a technology that would what? That would put the nail on the coffin of what? Of washing machine. No one will ever buy washing machine after that. You don't even need water, soap. You don't need soap, water. So that is very good type of research. No? And what do you mean by the rail record? It's a maintenance. So not only we are looking at the engineering application of design, construction, but maintenance part. Look at the bullet train. Since starting its operation up to now, there is no single derailment. If you compare to United States, the train has a record of about 30 derailments per year. Okay, per year. So bullet train is incomparable with the ordinary train. Because it is bullet train, you can expect to be derailed more than the ordinary train because of the speed. Because of the speed, it is potentially riskier in terms of derailment because it is faster. Okay, but it doesn't have because of complete maintenance. Okay, backlash. Okay, so another mechanical engineering problem, we usually encounter in gears. Okay, backlash. But since more and more demand for precision, backlash should be eliminated, and because of that, we develop an actual engineering innovation, what we call harmonic drive. Actually, they are not the one who invented the harmonic drive, but they innovated into present-day commercial use. So, invention are the result of research and laboratory output, but it is not still commercial scale. Commercial in Japan are complete with test and efficiency and acceptable effectiveness, okay, which are not requirement for research. Okay? Efficiency and effectiveness are not yet a requirement for research because they are only testing the development of a concept. Okay? The concept can be realized. But if the concept is now realized in other countries, Japan will develop the commercial scale. Okay? So commercially, it is now a very high quality product. So do you know what is the joint mechanism of Honda Asimo? Okay, the #1 humanoid robot in the world. Honda Asimo's joint mechanism is harmonic drive, and you cannot research it. And even now, currently, you can use your internet. There is no document that will show you that harmonic drive is being used in Honda Asimo. Okay? Okay? Unless you know it. You've seen it. Okay? So, what we have discussed in the previous page on rotary engine, the rotary engine is actually called Wankel engine because Wankel is the discoverer or the inventor of Wankel engine. Okay. So, where did Japan hide its product quality? Where is the quality hidden in the whole process? Why they are keeping on sustaining a good quality in their products? Okay. In our country, you and me have choices to decide on, and this decision have consequences. And ultimately, our collective effort will go in one or the other direction. So therefore, I am challenging you to look into alternative concepts, alternative ways, alternative methods, alternative techniques coming out of countries like Japan. Not only we are looking at Western research, we have also to look to researches, products, technology coming out from Japan. Okay. In the short allotted time, we will talk about the most magical way how Japan has turned around. So, because after World War II, this is what you can see in Japan. Sad state of social life. They are what? Piling up, falling in line just to get rice to cook. Rice is being rationed from place to place because of lack of available sources. Okay. What they have had was so low from the ruins, but they have patriotism, they have time, and they commit. Okay? They commit. Because of this, they bounce back. They learn skill, they develop simple technology and improve it continuously. Okay, so these technologies are in different areas, machines, tools, devices, and because of this, how to use those tools and technology. They are technologists, they are technicians and engineers. So they are what actually the best mechanical engineering practice in the world. Do you know that Japan is not the #1 electronics engineering? They have #1 electronics product, but they do not have #1 electronics engineering. They have very good mechanical engineers to automate electronics production. Okay? So the #1 engineering discipline in Japan is actually mechanical engineering. So they learn religiously in our university. We are just like PMA. So we are too disciplined inside the classroom, listening to our teacher. Okay. Looking forward, what they saw. Critical choices. Country over family versus the other way around. Actually, they choose country over family. Family and self are the last priority in their list. #1 is country, #2 is company, and their family. In our country, our #1 is God, country, family, and self, but that is only in our words, not in real life. #1 God, #2 country. That is not in real life. That is only in words. Okay? What do you want to, what do you mean by that? Because, for example, you have a son or daughter that is going to graduate, you will not ask for a vacation leave just because you are going to accompany your child into a graduation ceremony. No one will do that. There are Japanese parents that would accompany their child into a graduation ceremony only after doing all, and for example, they are not employed. They are not employed, they will accompany their child. Okay? But if they are not employed, when we graduated in college in engineering, I think I only saw 3 or 4 parents, and 3 of those parents, out of the 4 parents that I saw in our graduation, 3 of those are parents of foreign students. Parents of foreign students. So they are coming from, for example, Malaysia, Indonesia, because I do not have any Filipino class batchmate. So I do not have my own parents with me in the graduation. So I feel like I am one of the Japanese. So anyway, white and blue jobs. White job, those office type jobs. Blue jobs are those engineer jobs. So engineer jobs is the choice. They want to do things. They want to do things rather than say using just the words. What is the result of words? Can you have a product by words? Yes. What are the products of words? Music, song. Okay. That would get 1 or 2 or 3 or less than 10 person successful being an artist, singer. But if you are talking of the whole country, words is not what? It's not an investment for your family's income. Okay, you cannot expect that you can get an income for family's cost of living from your words. Okay, so we are talking of national scale. So more or less, engineers do the products. So we are the one who will create a product that could be sold, that could solve problems, and because of that, there is a demand. And that demand will create one economy. Okay? So blue collar jobs rather than white. Even if you are in the office doing the design work, not all the time. This engineering design job in Japan is in the office. We are designing, but we are directly involved in the actual testing, research, making the sample, making the jigs, making the testing environment, okay, the experimental setup, and later on characterizing its specification. Okay, for example, one of the best specification is how long does this product will last. Okay? If you have for example, hammer, how many times you can use the hammer? Okay? Of course, you are going to do it, test it, experiment, so that you know 1 million usage, this hammer will not break within that period. So how can you know 1 million? Because you tested it. So not only the design part, you are also involved in the actual many hands-on things. Okay. Primary versus quaternary industry. So we are in our country focused on information technology. This is the fourth level industry. Primary level industry are the mining, and because it is mining, it is an industry wherein mechanical engineers are involved. Okay. If we don't have the primary, secondary, third level industry technology, we cannot support the country. We can be at the fourth level industry by focusing on programming, information technology. Okay, but a foundation, we have that building. For example, think of our industry as a building. we need to have a good foundation before we have a good first floor, we have a good second floor, we have a good third floor, and before we can expect any good fourth floor. So that is what we are talking about, primary versus quaternary industry. Next one is quality versus economy. How much is the product? Too expensive versus one with very cheap price, but the quality of Japanese products are there. You can experience it. You experience it many times that you already know which one to choose. If you are given, for example, two products, you will always pick the Japanese product. Okay? Even if you are not the one who will buy it. For example, it is just a gift, you will pick the better quality. Much more when you are buying it yourself because you want to invest in a good quality. So not all the time cheap products win, but in our country, almost majority of our commercial products are cheap products so that the country will be able to afford. Okay, so there is a difference because we cannot afford very expensive ones. So there are only specific products that we want to have a good quality. And most of the time, we have cheap quality, no? But cheaper price. Okay? So precision, accuracy, also accuracy almost always cannot be reached, but precision is now on the level wherein errors is so negligible, so small that estimates is almost as if the actual accurate value. So laboratory test versus consumer feedback. So Japanese products are being tested before it can be offered in public as a commercial product, but in some culture, they are making the product as simple as possible and immediately bring it out in the market and just feel the feedback from the buyers. If the buyers are angry, they will make some adjustment, improvement, and then again put it out in the market. Again, feel the feedback up to a point that there is a balance between price and the demand of the market for certain quality. So if that is now balanced, the technology now stops. There is no necessary improvement because why do you improve when the public is or the buyers are satisfied already? No need for further improvement. That is one way of thinking. But another way of thinking is the Japanese way, the winning culture. They will continuously improve even if there are no demand for it. Products are continuously being improved. Okay. Country over family versus the other way. So in an example, one of which is the private sector, dynamism, and entrepreneurship. It became popular, became the primary force of rapid industrialization during the Meiji period. That is after the World War II. So policy was generally successful despite criticism. Policy support, that is Edo achievement, power, monopoly, and close linkage with big businesses. Privatization scandal, excessively pro-West, unfair by today's standard. Japan's economic growth was driven mainly by private dynamism. Okay. So, country over family. Not only in words, but in actual policies. Actual policy. Company policies. Okay? Not only in words. Not only in essay. If you are writing a good essay. But in real life, country is the last. Actually, in our culture, country is the last. We have ourselves, our family, God, and country. Right? That is a sad state of our culture. However, of course, it is not hopeless. It's not still hopeless. So we just need to look into alternative ways to be able to compare, and some of us would choose Japanese, right? Some of us would choose Western. So depends. Post World War II Japan, what happened? In 1970s, Japan took advantage of a highly trained and educated workforce to shift their economy toward technologically intensive products. And made in Japan came to represent a state of the art. This is one unified effort. It is almost impossible to do it in the Philippines because there is no unity. There is no unity. And every way of our aspect of our life, there are always contradictions. And the contradiction is so great, almost 50-50. Therefore, it would be confusing. It would be confusing, 50-50 contradiction. For example, in every election, 50-50 who will win. And I would not delve into that topic because that is the saddest aspect of our culture, politics. So, made in Japan, culture. A culture of making those products really, really state-of-the-art quality. MRA versus sport level, just like I said, we take for a moment. Japan is very low in the sport level of the information technology 20 years ago. Okay. Sport level industry is the last industry level that developed in Japan. Okay. And actually, most Filipino information technology and engineer could beat Japanese, even up to now. However, we don't have the ways and means to commercialize, because if we commercialize, there are so many factors involved. We cannot even manufacture our own processor, microprocessor. We are talking of information technology. Then we manufacture our own chip, for example, video RAM. Okay, video RAM. Then we manufacture video. In our alma mater university, there are motherboards that came from that university. Motherboards researched by the thesis research by the student and teacher and become commercially viable product, which is motherboard, type of motherboard. Okay. It is not actually used in the general computer, but in industrial type of computers. Industrial type of computers meaning those devices like programmable logic controllers or PLC. Okay. So quality versus economy, take a moment. And the way of life, no quality. It is the only country that you can get comfortable in toilet or in a bathroom. Okay? They have very clean bathroom or toilet. Okay? Wherein you can have so many functionalities. You can see the buttons functionality. Stop, rear cleansing, soft rear cleansing, front cleansing. Okay. There are even soft music, volume. Music volume, type of music. So doing this logical activity is very comfortable. That's why they are called comfort room. Okay. They are not the inventor of comfort room. Even the word comfort room is not invented in Japan. But look at the comfort room invented versus the current state of comfort rooms. Will you buy the inventor of the comfort room or Japan comfort room? That is a real situation. Okay? It's a reality. That is a reality. Precision versus accuracy. It is too technical. This is actually one of my major precision engineering, machining. We started to learn lathe machine, milling machine. Then we go on to learn CNC lathe machine, CNC milling machine. Then we go to learn machining center. Then on our fourth year, we even have what? Laser machining. Yes. So, too good to be true. We are talking about country. Actually, we have the better equipment, we have better devices in our school laboratory compared to high-tech companies. For example, Toyota, because we are familiar with Toyota, because we are having what? OJT or plant visit, and we saw that their equipments are actually not the same with our equipment being used in our school. We are using the latest model in our while they are using about 5 years old model in their industrial plants. So that never happens in our country. That never happens in our country. Even the best school in our country do not have that kind of culture. Okay? Best laboratory in engineering school in this country. What is the model of, for example, lathe machine? What is the lathe machine model? Or what is the laser machining model? Or what is the machining center model? Or the milling machine compared to the industry? Compare it to industry. Compare your equipment in the school to the industry. Let us see. Use as an example the best or number one mechanical engineering school or laboratory. Mechanical engineering laboratory in our country. Okay, so it will take many years from now before we can have that type of culture. That's why the industrial companies are waiting for the research result of schools of the academy, because they know they have the best tools, they have the best devices, they have the best equipment for research. If you are researching and you don't have the best equipment, what will be expected of your research? So, okay, so the research laboratory are the best place for the best or the high-tech level of machines, okay, and equipments. So, laboratory test, this is consumer feedback. So, either one or two. So, consumer feedback, we just wait for the demand to be able to move or improve our product. While laboratory tests, we are doing our best to think of improving our own product, then later on offer this to public. Realization of different streams, not on what? Manga, it's in everyone view. Particularly, you are what? Millennials? You know, you are what? Computer native. Okay. Information technology natives. You are internet natives, because as soon as you know how to use your hand, you are actually using cell phone. As soon as you know how to use your fingers, you are actually looking for YouTube or internet or games in in gadgets. Okay? So you are what? IT natives. Similarly, several manga come from Japan. We have Japanese engineers and technicians. Actually, Japanese engineers, technologists, and technicians. Okay, so we have the discipline pertaining to skill, science, and technology. They have to study, gain experience with the following behavior expected of them: discipline, honor, pride, preparedness. Be number one. Number one culture of Japanese engineering: preparedness, committed, skill, technologies, and know-how. Know-how is the detailed knowledge, not the knowledge which is theoretical, but if we say know-how. That is the knowledge that is gained through actual experience. For example, if you are given a device and a screw, how much rotation will you apply in order to say that you have the most efficient and effective way of joining two parts by use of screw? You have the most effective and efficient way. How many rotation? You cannot answer it if you do not have the actual experience. Okay, so that is what we mean by know-how. It is knowledge gained from actual experience that almost nobody could teach you. But you can apprentice helping an expert, and that expert will show you how. Okay. Example, you have real samurai and robotic samurai. Still, human being is the best. Is better than machine as of now, but we do not know in how many years that would reverse its expectation. There will become a time that robots will be more efficient, effective, and useful than human being. We don't know. In the near future, maybe. So we have several talented engineers. This one is one of them, which is actually the owner and founder of DTEC Corporation. Okay, which is one of the most popular technocrats in Japan. Technocrats, they are engineers that become entrepreneur, and because of that, become very wealthy. So technocrats. He's the one who innovate the brushless motor. Brushless motor that is so small to be used in what? In hard disk, hard drive, optical disk, optical drives. So he partnered in IBM to produce those hard disk, hard drive, and was very successful. Okay. There are several products right now, but he is one of the most popular technocrats in Japan. So, for example, here they are producing motor as small as the one you can see on the left, and as big as the one you can see on the right. That is the pump motor, but 2 times as tall as a human being. So if that human being is 5 feet, so the motor is about what, 10 feet, which is about 3 meters. Imagine that motor. And on the left, very small vibration motor. Okay, you can put about 5 vibration motor in one of your fingers. Okay, just look at this scale. So micro to super large one. That is technology. Very different technology to manufacture small. Very another set of technology to manufacturing. Totally different types of problems that you would encounter in this one. So the range is so great from micro to super large. So this is still the same person, Nagamori. He was even featured in manga. So if you are an engineer and become a manga character, he's a real manga character made by manga authors, manga artists. Okay, so if you reach that state, then you can say you are successful. He was featured as a manga character in a manga story. Okay, so we can say that another alternative perspective way of life from an engineer: passion, enthusiasm, tenacity. Tenacity. Tenacity meaning failure cannot obstruct your focus. That is what we mean by tenacity. Failures cannot stop you from going ahead and be successful. That is tenacity. Okay, couple that with enthusiasm and passion. So this set of characteristic or traits is a winning characteristic that we have yet to encounter. So we know passion alone, we know enthusiasm, but this combination will work. So winning culture. Most of the engineering company has this. Why? Because they are related from the samurai culture. Okay, they are related to samurai culture of skill, science, and technology. Okay. So therefore, what is the recipe for success that we could gain from this discussion? Never give up. Never give up. That is tenacity. And you never give up. And you do it with so much joy, passion, and enthusiasm. So what you can see in your right picture is the apex seal. The apex seal are the three seals located on the corners of some sort of triangle. Triangle, but that is not triangle because that is curved. That is not a straight line. The sides are not straight line, so it looks like a triangle. But the most important thing is apex seal have to be located on the corners of that to be able to what? To seal the different dynamic chambers. There are three chambers that is dynamically moving. So passion, again, enthusiasm, tenacity, means intelligent, hardworking. Do it now. Do it without fail. Do it until completed. So expect failures, but do it without fail, meaning you can bounce back. You bounce back. Okay, you bounce back. Okay. So do it right away. Do not do it tomorrow. Do it right now. Start it today. Okay? So we have a recovery because of that. So many technocrats followed in Japan. So many technocrats followed. And there are several Nobel Prize winners pertaining to scientific research. And the Japanese recovered, producing so many types of steel. That is actually the what? The primary and secondary level industry. Okay. They have all the processing, efficient, effective processing of raw materials into usable engineering materials. They do not have so many natural resources. Japan do not have so many natural resources. For example, they are buying steel ore from us, iron ore. They are buying iron ore from us then. They will process it, and then if they produce steel and we buy steel, totally expensive already. Actually, we cannot buy. We are not buying steel from Japan. We are buying steel from China. But we are selling steel or iron ore to Japan because they buy it with higher price. No? They are buying it in higher price. But after they process it into a usable form, that is too expensive and we cannot buy it anymore. We buy instead. Those are from what? Vietnam. We're buying from Vietnam, we're buying from China. And if ever we want a good quality, we are buying from Korea. You cannot buy steel from Japan. Too expensive. Okay? That's a real happening right now. Okay? So, automation. Japan became the first major user of industrial robot in manufacturing. These were first developed in US, but Honda's first robot, right? No? That is the Honda's first robot in automotive manufacturing. And Honda showed it in their what? Humanoid robot called Asimo. Okay. They have advanced recycling technology. So with being a waste collector, being a trash collector is not a bad job in Japan. It's not a very different poor type of job in Japan. Okay? That is not actually being considered as bad smelling job. So waste collector, trash collector is not. Okay? Some people are actually dreaming of becoming a trash collector in Japan. They are a career in Japan. Okay? And the waste truck, trash collector truck are clean. They are clean. Okay? So, unlike in our country, if the waste collector truck pass by, the whole street will smells very bad for a couple of minutes. Okay? And that's why it's very different. They are always looking to improve quality and way of life. Dirty hands, meaning they are engineering work. But look at the actual hands. Because of engineering technology, supposed to be this type of job will really dirt your hands. But because of the level of technology, the automotive mechanics are not a dirty work in Japan. But look in our country, if you just visit the auto repair shop, you yourself become dirt. You yourself will become what? Susceptible to dirt because of dirt all around. So very different. If you visit the automotive repair shop in Japan, they are very clean, very different. So because of added effort for discipline, cleanliness, technology, advancement, so we have what? Polytrain. So there is no single occurrence of derailment since it started 20 years ago, 25 years, 30 years ago. There is no single incident of derailment. So we have Asimo with motion now currently moving as if the rate of movement, the smoothness is become nearer and nearer to human being. Okay. Thank you very much for listening, and I'm challenging each and every one of you. You are the future mechanical engineers, and therefore you are the future producer of products. And I should challenge you that you have to produce quality products. Okay? Quality products. You have to design quality product. You have to construct quality product, and you have to maintain it properly so you have almost no downtime, zero downtime, zero waste. Okay, and I have here my contact information on YouTube and Facebook. Again, this is Dr. EYPEI, preaching engineering for nation building.